All right, let's jump right in. Welcome to This Explainer. Today, we are unpacking a literally shocking economic disruption that is happening right this second on the August 2026 AI leaderboards. We are looking at a fundamental shift in how we value and, more importantly, how we price artificial intelligence. And it is all being driven by a model called DeepSeek V4 Flash High. So if you're building with AI, if you're budgeting for it, or even if you're just keeping an eye on the cutting edge, the math we're about to go through is going to change how you look at everything. To really grasp why this is such a massive deal, we need to focus on just one number: 9. 9 points. On the widely watched front-end code arena board, the model we're digging into today sits exactly 9 points behind the second best model in the entire world. In a game of absolute inches, being just 9 points shy of the silver medal is an unbelievable technical achievement on its own. But you know what? That is not even the part that's completely disrupting the industry. The contrast here is just staggering. You've got DeepSeek V4 Flash High trailing by just those 9 little points. But the model beating it, the number 2 model, it costs roughly 15 times as much. Think about that for a second. You are giving up a tiny fraction of a percent in performance to save 15 times the price. And hey, if you absolutely must have the undisputed top spot, the gap to number 1 is 128 points, which equates to about a 7.5% performance difference. But bridging that 7.5% gap, that is going to cost you about 82 times the blended rate, 82 times the price for single-digit percentage gains. It's literally like buying a private jet just to get to the grocery store 1 second faster. Okay, Section 1, under the hood of DeepSeek V4 Flash High. So what's actually driving these insane savings? Well, it's not just brute force. V4 Flash uses a sparse mixture of experts' architecture. It boasts 284 billion total parameters. But here is the magic number. Only 13 billion of those are active per token. That means only about 1/22nd of the network is actually firing on any given step. Because it is just so incredibly efficient at runtime, the blended price for an arena workload lands at an unbelievable 25 cents per million tokens. Now, you're probably wondering what the high in the name actually means. Just to clear that up, it's not some separate premium model. It is simply a reasoning effort setting on the standard V4 Flash checkpoint. The listed API price card, that stays exactly the same. But when you crank that setting to high, the model generates more internal reasoning tokens. And since you're billed for output tokens, your actual invoice cost goes up per task, which is what drives that blended 25-cent rate. But the baseline efficiency of the model remains completely untouched. But honestly, here is where this whole thing goes from a neat API trick to a total industry earthquake: the MIT license. This is a spec sheet line. It is not a footnote. It is a materially stronger grant than that vague open weights label we see thrown around so often these days. The MIT license explicitly permits commercial use, modification, and redistribution. There are no bespoke acceptable use policies you have to constantly monitor, no corporate gatekeepers. For anyone out there building sovereign or local first infrastructure, this is absolutely the holy grail. Which brings us to Section 2, the real story, the post-training revolution. If we track the timeline here, back on April 24th, 2026, the original V4 Flash dropped. This is what's known as the 0420 checkpoint. Fast forward a bit to July 31st, 2026, and DeepSeek ships a new checkpoint, 0731. They added native OpenAI Responses API support, codex compatibility, and this really clever speculative decoding module called DSpark, which is essentially a software trick to guess and generate text way faster. But the absolute most crucial thing here is that this was a re-post training of the exact same underlying architecture, no new parameters, and no new price. Because both of these checkpoints sit on the arena board simultaneously, we can actually measure the exact impact of that July update. The April checkpoint scored a 1432. The July update, a 1577. That is a massive 145-point jump achieved on the exact same parameter count and architecture. There's a quote that really hits the nail on the head here. A 145-point move from post-training alone, on frozen weights at frozen prices. For years, the whole industry assumption was that to get a massive capability jump, you needed massive new models, which meant hundreds of millions of dollars in fresh pre-training compute. But this proves the binding constraint for frontier capability is no longer just brute force pre-training. It's what you do to the network after that training ends. And that lever, it is dramatically cheaper to pull. Now, as pumped as I am about this, let's do a quick reality check and address the statistical noise. Arena actively marks this rating as preliminary. It's based on 1,319 votes, which sure sounds like a lot, but it's really only about 0.26% of the board's total data, and it carries a plus or minus 18 uncertainty. It is literally a one-day-old rating on a very young row. But there is a very good mathematical reason we can trust the general neighborhood of this score. Arena uses a true skill rating, calculated as mu minus 3 sigma. Basically, they take their central estimate and aggressively subtract 3 standard deviations to play it safe. It's an intentionally conservative math that deliberately reports things rose lower than their true estimate. So even if a run of early favorable pairings slightly inflated things, that 1577 score is largely acting as a floor. It should actually go up as more votes pour in. Moving right along, Section 3, the arithmetic of the frontier. Think about the Pareto frontier here, the set of options where absolutely nothing else beats them on both price and quality simultaneously. If you analyze the jump from the cheaper Laguna model to DeepSeek, and then compare that to the jumps from DeepSeek to GLM and Claude above it, you realize the price and quality axes have become entirely disconnected once you move past the DeepSeek point. Let's break down this brutal math for a second. Stepping up from Laguna to DeepSeek costs you just 7 extra cents per million tokens, and it buys you a massive 273 points of capability. But stepping up from DeepSeek to the next tier, you buy only 9 points, literally a 0.57% improvement, and you are paying 15 times the price for it. Talk about severely diminishing returns. So are the absolute top-tier models still better for super complex, highly specific tasks? Oh, for sure. For a certain class of tasks, paying 82 times the rate is totally worth it. But you cannot forget that the pricing of that top-tier band is now set against an MIT-licensed floor. DeepSeek just established a permanent, high-quality, fully open baseline. And floors like that, they do not politely go away. Let's look at what this means on the ground. Section 4, the local first reality. Because this isn't just some cloud-based theoretical stuff. The V4 family stores its expert weights in highly compressed FP4, with the other parameters in FP8. Thanks to this extreme file compression and that 13 billion active parameter sparsity we talked about earlier, this 284 billion parameter absolute beast can actually run on a 512 gigabyte unified memory Apple Silicon machine. The compute you need is really just similar to a mid-sized dense model. It's a tangible reality that you can download and serve commercially tomorrow. But let's weigh this fairly, right? The bull case is the dream: absolute sovereignty, total data control, and the freedom to modify and fine-tune a frontier-class model on your own hardware without any license restrictions. But the bear case is just as real. At 25 cents per million tokens, just calling the DeepSeek API is honestly cheaper than paying for the electricity and the depreciation of your own servers. Plus, we've got to remember that vendor benchmarks are notoriously sensitive to how the testing harness is set up. You definitely buy sovereignty with self-hosting, but you don't necessarily buy savings. All right, let's summarize the core economic disparity we've been unpacking today. The dispatch here is remarkably simple but completely profound. 9 points costs 15 times the price. 128 points cost 82 times the price. The premium charge for marginal gains at the absolute top of the AI frontier has reached genuinely staggering proportions. Which leaves us with the ultimate question, the one every single builder, enterprise, and developer has to answer right now. With a frontier-class MIT-licensed model sitting right at the inflection point of the cost curve, what is capability actually worth to you? Are those last few percentage points really worth the exponential markup? It's a question that completely redefines the modern AI budget. I'll leave you to ponder that one. Thanks for joining me on this explainer. I'll catch you next time.